Thank you to the organizer for inviting me here to this great conference in this amazing city. My name is Marco Consolaro. I learned to code when I was 9 years old on a Commodore, and I developed software ever since. First at school, I used to do COBOL at high school, then at uni, and after I started to work as a developer. As you can guess from my accent, I am Italian, but I live and work in London, UK since 2006. That's where I've learned a lot of stuff that I will tell you about something today. Currently, I work as a technical coach for a startup called Kazoo in London, which is not yet known, but hopefully you will hear about it very soon. We will go live with our website next week if we hit the deadline. This talk is about connaissance, and I choose to put this quote here because it is the quote that is in our book, in the chapter about connaissance. This is the, among other things, I am also an author. This is the book that we just released together with my mentor here, Pedro Santos. If you have been here before, the talk before, he was telling about mob programming in our coaching session. And the talk of today is a little taste of how our coaching sessions are. This is going to be quite technical, so I hope you don't fall asleep when I show some code later. I know developers will not. Why did I choose this quote for the chapter of connaissance? Because I really like the paintings of Van Gogh as a metaphor for connaissance. If you ever see a painting of Van Gogh in a museum, something I really like to do is to go very close to see the technique of the painter. And when you go really close, you realize that you miss the picture, and you start to see something like a random mix of colors. And it's only when you step back that the picture comes together into your eyes. And connaissance is a little bit like that. It's, I like to call it as the building blocks of our code. Our software systems are plenty of connaissance. Connaissance is what allows the information to flow, and that's what our system do. And the way that this information flow, for you, maybe might seem banal, right? But as we see together, there are many, many ways for the information to flow. So, the first time I heard about connaissance was in Codurance, when I heard it from Pedro. And as soon as I heard this thing, I was like, oh my God, I don't know anything about it. So I went on the internet, I found the video of Jim Weirich. So I want to play for you a little introduction about it from Jim. It's just a 3-minute video, which I think it's very, very good.
But we have a lot of different principles proposed by a lot of different people, and I'm wondering, is there something that kind of ties all these things together in an interesting way? And to investigate that, I went back and, so what I'm looking for, in essence, is the grand unified theory of software design. I want to have a small set of principles that talks about what makes good software and kind of get past the kind of higher level principles here and look for something a little more fundamental than what we've been working with so far. So the title of my talk really is The Grand Unified Theory of Software Development, but I felt that was a little pretentious to propose for Yao. But this is really what I'm thinking about. I want to look for those underlying principles. To get there, I went back to a book written in 1996 by a fellow named Miller Page Jones. And he wrote a book called what every programmer should know about object-oriented design. Another pretentious title, perhaps. But in this book, it's divided into 3 parts. The first part is a basic introduction to OO. If you've used Ruby at all, basic OO is simple to, you've already covered that. The first part of the book probably won't buy you much. The second part of the book is a notation for drawing out diagrams representing object-oriented designs. This book predates UML. This diagramming notation he talked about here is pretty well out of date. So the second part of the book, probably not all that useful, but the third part of the book pays for it all. He talks about an idea that he calls kinesis. Now, kinesis is a real word. It means the common birth of 2 things at the same time, things that are born or produced with another, or the act of growing together. And it's this third definition we're kind of focusing on. In fact, I want to define it technically now. Kinesis, in my terminology, is just that 2 pieces of software share kinesis. When making a change in one of the pieces of software, requires a corresponding change in the other. In other words, if I have a module over here and I make a change to it, and that forces me to make a change to this module over here, then there is something between those 2 modules. Now, we normally call that coupling. And coupling is a perfectly good term. I'm not trying to replace that term, but we have so many ideas of what coupling is. I like to reserve the word kinesis for particular kinds of coupling. And what we're going to introduce today is kind of a nomenclature for coupling, a nomenclature for kinesis. And by using this nomenclature, all of a sudden, I claim, we'll be able to start reasoning about our designs with some very, very, very basic principles of modularity.
So I have seen this, and I was sold out. I was like, now I want to learn everything about Connascence. I watched all the video of Jim Weirich. They are fantastic. If you program in Ruby, perhaps you find these examples better than mine. And actually, after this video, I was like, oh my God, I have a lot of questions for him. And I researched him, and I wanted to write to him. And I discovered that Jim Weirich is not with us anymore. This was his last commit in February 19, 2014. And this was the day that he left us. Jim Weirich was a great programmer. He wrote the rake build script for Ruby, other contribution for the Ruby community. So please join me in an applause for his memory. Thank you, Jim. So let's go back. Connascence. It's from Latin, right? Co-nations. We are in Spain here. You are more used with Latin than my UK friends, right? Co-nations. Nation is to be born. Co is together. So birth and grow of 2 more things at the same time. So 2 more elements: fields, method, classes, parameter, variables, build scripts, configuration, anything really are connascent if a change in one element will require also a change in the others. It is essentially a taxonomy to reason about software in 3 dimensions. There is a degree, which is the size of the impact. There is a locality, which classifies how close or far apart are the elements that participate in connascence. And there is a strength. There are different kinds of connascence that are different in strength. It means that some are more easy or difficult to change based on their strength. It's basically something like this. We have 3 dimensions, and what connascence does, it gives a direction for refactoring. So every time that there is a high degree, we should try to make it lower. If we have a strong kind of connascence, we should try to make it weaker. And if the locality is apart, we should think about redesign to get these pieces of connascence more close together. I know what, how many developers are here? Oh, good, so that's true. I know what you are thinking. show me some code, right? Okay, so let's start. I hope you don't fall asleep. Let's see this class, right? It's a class that represents time. This is a constructor with 3 integers, right, like that, and then it displays the time, right? What is wrong with this? Apparently, it's not. But this class has a few kind of connascences in it. Let's see some. Let's see the good kind of connascences, right? Let's see this. If I change this hour, and I call it hour 1, for example, that forces me to change also this part of the code, right? They need to reflect the information. And to do that, we need to change them together. In effect, if we have an IDE, and we change this one in hour 1, and then we change this one in hour 1, this one is going to be an error. Or if we change these 2, and this one become gray, it's gray out, it's not used. So that's the principle of connascence, and this connascence is everywhere here, right? This kind of connascence is a good kind of connascence. It's called connascence of name. There is another kind of connascence that is related to that. Let's look at this type. If I change the first hour here in a float, for example, I need to change also the type of the parameter, right? Because those types are connascent. And the same is valid for the other parameter. This is another kind of connascence. It's called connascence of type. So let's see, where does this play in our ladder of connascence? Is it weak or strong? Well, connascence of name or type are weak, are the good kind of connascence. This is how our code should transfer information everywhere. But it is not always like this, right? This is a static connascence. It's a kind of connascence that we can discover with our compiler. Let's see a different class. Let's see this notificator, right? And see a different kind of connascence. This notificator needs to be used like this, right? It has a send email, and we have a string, which is a recipient, a string that is a sender, and a string, which is a message, right? When we use it and call this send email, what we do here is inserting 3 strings. We start to make, with the clarity of this method, start to fade out, because actually I'm always, in this kind of situation, I'm always uncertain. Is this one the recipient, or is this one? I need to check the method definition all the time to see what is what, right? There is a relation between the position of the parameter and its meaning, right? The first is the recipient, the second is the sender, and the third is a message. We relate the position of the parameter to its meaning. This is called connascence of position. Connascence of position happens when multiple components must be adjacent or must appear in a particular order, even often passed like a positional structure, like an array or a tuple, right? It's easy. Like, oh, I need to pass more parameters. Let's make an array, right? It sounds a good idea when you do it. Then when you use it, you realize you don't know how you have to build that array, right? So how strong is this kind of connascence? This is pretty strong. It's the strongest one of the static connascence. And how do we fix it, right? Well, we can fix it like this. This is a way, right? We can actually create a type. One is a recipient, another is a sender, the other is a message. So now, when we instantiate this, we can understand what it is because it is embedded in our type system. It's what we aim to do in object-oriented programming, right? Now we have a clear meaning for this. And we actually, what we have done, we reverted back to our beloved connascence of name and type. Let's see another better way. instead of having 3 objects, we can create a notification object because this is a notificator, right? So we can use a object that represents that, and it's still connascence of name and type. Let's see how the degree plays an important role in connascence of position. Because if we have a method that receives something, like here is a tuple, right, with 2 elements, and here say, okay, process order, if the Boolean is true, send also the invoice, right? Here, when we read the code, it's still kind of understanding. It's not perfectly clear, but we can quickly work out. In this kind of method, what does this stuff do? Okay, process order, then send the invoice, then notify the employee with what? Item 1, item 3, item. It's the meaning of that method fades away completely, right? This one, the first one is a connascence of position of degree 2. And the second one is a connascence of position of degree 5. Let's see what happens when we try to call it, right? This one is degree 2. Yeah, order true, okay. This one is degree 5, is order true, an ID, daytime, jack, false. That's in my mind, it's like, what the hell is that, right? I'm like, that's what happened when I code like this. And this is the problem, right? The higher is the degree of connascence of position, the worse it is, because it makes it completely ununderstandable. Let's move on. Let's see a different one, right? Let's go back in our example of before. Right? Now, if you paid attention, I know it's difficult because code after lunch makes you sleepy, but if you see here this constructor, we realize there is connascence of position over there, right? But there is another kind of connascence in this class, which is perhaps very, very bad, worse than that. Let's see, what happens if I instantiate this class like this, right? This is not a real time because the hour 27 doesn't exist in my clock, neither the minute 76 and the second 82. So what happened here? If we instantiate the class like this and we do not validate, we basically have an object with an invalid state participating in our information flow. And that might cause very, very unpredictable behavior somewhere in our application, right? So this is a typical example of connascence of value. Connascence of value happens when 2 or more components' values are related or have an intrinsic range of validity in their input not expressed by their primitive type, right? Here, there is an intrinsic range of validity. We know that an hour is 0, 24, right? Or 23, right? See the ambiguity here, right? So, how strong is this kind of connascence? Well, pretty strong, not very good, right? So, how do we fix it? Well, as a bare minimum, the class should participate in the information flow if and only if its state is valid. So we can validate. As a bare minimum, we validate it and don't allow the invalid state to be passed on. But there is a much better way to fix it, right? Guess what? We can use our type system. We can create an enumeration or a class that represents our parameters so that it's basically impossible to make it work. We use connascence of name and type to make the invalid state unrepresentable. Next, let's see a web example, right? Let's imagine we have a checkbox like this. And in our controller, we have to identify the transports that the user take in a checkbox, right? So I've seen this all the time. We say, okay, so let's make a convention. Number 1 is bike. Number 2 is car. Number 3 is train. Number 4 is bus, right? Perfectly fine. I've seen it many times, right? The thing is that here what happened is that we are giving a particular meaning to some arbitrary value, right? This is called connascence of meaning. Connascence of meaning happens when 2 or more components must agree of the meaning of specific values, hence using a convention. How strong is it? Not very strong, but the problem is that it's easily fixable, right? Let's introduce a constant, for example. Right? If we introduce a constant like this, there we go. Now, there is not ambiguity anymore. We understand what this means, right? We have used, again, connascence of name and type to solve this kind of connascence, to make it weaker. Next, let's see this code. We have a piece of code here that do easy checksum. It sums the value of this number and then make sure that the last number make the whole number divisible by 10, right? It's an example. It's what happens when you download a file and want to check if the file it has been tampered or not, right? You download it and then apply the same algorithm and check if the 2 algorithms match in the value. That means that the content has not been changed, right? That's a trick to verify a file, but in our code, the same trick is not as good, right? Let's see what happens if we implement it in this way. We have here the calculation for doing it, and then here we have the same calculation for checking it, right? This is actually the same algorithm. And if you know code smells, you will recognize this is a divergent change, right? If we change this algorithm and say, okay, let's make it divided by 12 instead of 10, we need to change it also here. By textbook example of divergent change. This is also connascence of algorithm. Connascence of algorithm happens when 2 or more components must agree on using a particular algorithm. How strong it is? How strong is it? It's quite strong, and it is still very easy to fix. We can just wrap the algorithm in its own method in this case, but if it's called by more places in our code, we can extract it in its own class. And it's still connascence of name and type. Let's see another one. This one is quite interesting. Let's suppose we have a piece of code that need to send something to the customer and then archive that thing, right? Here, the problem here is that if we archive this before we send it to the customer, it's not gonna work, right? So there is an implicit order that we need to call the method of this class in order for it to work. This is called connascence of execution order. Connascence of execution order happens when the caller of a component must have some unexpressed knowledge about the correct order of the methods to be called. How strong is it? It's quite strong, but it's the less strong of the dynamic kind of connascence. That is because if you think about it, connascence of execution order, it is there in all we do, right? Of course, we need to do something before something else. It's all what we do. It's the kind of a procedural program. It's just you do before this and before that. The problem is when we design our system without making it explicit, when we leave to the guessing to the programmer what is the order about the thing we have to call. And let's see this example. Let's see the builder pattern. This is a very nice example, right? we set up the builder and then build the car in this example, right? And here, there's no particular order. We have to call these methods, right? But what happens if we have to call these methods before this one, right? Otherwise, it doesn't work. This is connascence of execution order. So is it, in the builder, it is expressed by convention because we say, okay, it's a builder, so I know that I need to set it up before I build it. But can we make it better? Well, let's see what we can do. We can perhaps segregate the interface and say, okay, so I can break down the interface and say that I built cars with brand, and this one can return me I built cars with engine. And then this one will return me I build cars with color. And then it returns me the I build cars that give me the concrete. Let's see how the builder becomes. We inherit from all of these, and then we use a private factory method in order to force the builder to return this interface. And so when we call it, when we use it, it becomes immediate. You cannot get it wrong, because when you create a new one, it gives you an arbitrary brand. You have to give it the brand, and then it asks you the engine, and then it will ask you the color, and then it will return the final interface for build it that return the contract. We use connascence of name and type to express the order of execution of this builder. So, another couple of kind of connascence in our code. This one is thread slip. How many times have we seen that? This is a piece of code about testing some message bus, right? We need to wait, because we need to wait for the message to be received, right? So this is Kinesis of Type. How many times you see things like that, and you say, oh, this doesn't feel good. It's not right. And say, why? Because it doesn't feel good. It doesn't really have a name. Well, now you know it has a name. This kind of thing is connascence of timing. Connascence of timing is when the success of two or more calls depend on the timing when they occur. A race condition in multithreading, for example, connascence of timing. How strong is it? It's quite strong. And how can you fix it? Well, it's difficult to fix because the connascence of time is there, right? You can mitigate. For example, here, this is a code from a real-life example. Here, I actually decided to raise an event. To raise an event in order to know when the message arrives and limit the connascence of type only on the unhappy path to speed up the execution of the tests. Last piece of code, right? Not last, there will be one later. So this is a global counter, a controller that receives a global counter. This is a singleton, pattern or anti-pattern. I don't go there. I don't want to trigger that kind of discussion. But if it works only for that instance, we have connascence of identity, right? That's why some people call the singleton an anti-pattern, because they fall into this problem. And connascence of identity happens when one or more components must reference exactly one instance of another entity to work. How strong is this one? It's pretty strong. It goes there right almost in the top. And how can you fix connascence of identity? Well, it's difficult. That is, it's about redesign usually. You need to re-architect the system. For example, in that global counter could be extracted and work asynchronously, receiving messages instead in memory. When we wrote this chapter of our book, I actually happened something to me. I was working in a company in London, big company, I don't do names, but I was in a team there, and something happened that made me understand that perhaps there is a different kind of connaissance that is even worse of this kind of connaissance that I show you until now. So we invented a new kind of connaissance. I tell you the story now to tell that. So basically, I was in this team, and I was working this messaging system. And I was creating a new message type. And when I tried in my local machine, I had to change some configuration for the new message type. I didn't like that, so I changed the system in order to don't need configuration in order to accept a new message type, right? It's some crazy. Every time I add a message type, adding a piece of configuration, it's too much work for me. So what happened is that when I work in my machine fine, when we went in the integration environment, it stopped working. And no one knew why. It should work. And what happened was that they were able to couple themselves to the building script. So basically, every time they added a new message type, they had to change the building script. The connections were so far away that no one was remembering that. We needed to investigate the problem after we saw the integration environment failing, right? I was like, wow! That we decided to call it connaissance of manual task, when expanding the functionality requires some tasks to be executed outside the code base, so manual task, right? Where does it go? Well, for us, it goes on the top, because it goes against what we do. We do automation, right? So add the node manual task like this, and team will spend more time fidgeting with configuration and script instead than well-designed code. Who said so? Myself. Sometimes I like to quote myself. So, conclusion. It's all about design, as Pedro says, right? I really like this sentence. We know the past, but cannot control it. We control the future, but cannot know it. This is very nice, but in software development, it is not strictly true. We can change the past. It's called refactoring, right? So why does Pedro say it's all about design? Because if you have good design, you can keep refactoring very often, and you can improve the effectiveness in the long term. If you have a bad design, it's always more difficult to do refactoring, and its effectiveness, it has just a very short time of benefit. It works like this. In the past, we have coupling, cohesion, connaissance, design smell, code smell. We have ways to analyze our code. In the future, we have principles, we have practices that guide us to have a better way to write our code. So the thing is that everything is together. If we look at this piece of code, order flow, execute, generate an ID. Here there is a connaissance of position. It's a long parameter list code smell. It doesn't have single responsibility because this stuff generates an order ID. So there's low cohesion. And we have data coupling and primitive obsession because we pass primitive around these methods, right? So what happens if we fix connaissance and we have something like this? Fixing connaissance will solve all these problems in once, right? Just using connaissance of name and type, as always. Because what we realize is that all our tools are connected. If I fix connaissance, I fix cohesion. If I fix coupling, I fix connaissance and cohesion. It's everything connected because we postulate what we are in effect doing is minimizing the system entropy. Considering entropy, one of the many definitions, as the degree of disorder in a system. That's what we are effectively doing. So, I finish. Once upon a time, my friend Saiplo, a great Rust developer I met in Codurance with Pedro, asked me, why should I learn about connaissance? Give me one reason. I will say, well, because continuous attention to technical excellence, a good design, enhances agility. What is this? You know what is this? This is the 9th agile principle. Apparently, forgotten for a few years, right? I wonder if people know that Agile has been funded by a group of developers, right? Sometimes it didn't really seem so. So, I finish with the last quote from my book, and I will say, learn the rule like a pro, so you can break them like an artist, and this is Pablo Picasso. You should know it well. Thank you.
We don't have any questions in the application. Is there any question here? Okay.
I was a developer before, but I'm a Scrum Master at the moment. What can I do for my team to help them better their code in terms of education?
Where are you based?
Hamburg in Germany.
My friend here has an amazing coaching company, but they are based in Barcelona. I should get his detail, maybe he can send. Yes, I think, apart jokes, it's really important from a Kaizen point of view to, I don't know how familiar you are with the Toyota production system and Edward Demings and those kind of ideas. I think that is where the root of everything we do start. And what they do there, they embed coaching into work business as usual. So, and it's the same I am trying to do in my startup. Everybody wants to be busy, busy, busy with delivery. And what I'm saying is, no, you can't be 100% busy on delivery, because if you, and neither you cannot be 100% busy. You need to have slack time. I said, you should have 30% of your time spare without plans. And say, oh, so much. Yes, of course, because if you are focusing on doing, you stop focusing on thinking. And if you don't think, you don't know what you are doing. And so it's better to do less, but do well stuff, do the right stuff, do the good stuff, than do a lot of mediocre stuff. So it's about time managing and embed the coaching program. What I'm trying to do there is to create a coaching program where the people can sign up and have 1 day spare per week to use in coaching activity. And that is from medium to senior. When the senior gets at a certain level, he doesn't have to participate to the coaching program as a participant. He has to run and coach the other developer. Instead, that's the next level to principal. That's how I would do it.
Thank you.
Hi, thanks for the talk. It was super interesting.
Thank you.
Do you have a kata or something related with this concept so we can work on it? Or
Yeah,
should we go directly to our code?
Well, of course.
We have the book already.
Oh, thank you, thank you, thank you. Thank you. Well, there are a few exercises, yes, that we run with this. I'm not sure if we have something specific prepared for this. Okay, let's see. We are working on it. We are working on it. We have seen a lot of success in our smelly tic-tac-toe. Actually, we did some mob writing. I wanted to interrupt before Pedro when it was about mobbing, because the smelly tic-tac-toe we create in a remote mob programming. I think I was in the Philippines. Me, him, and the other author, and we were like, oh, we need to create a very nice exercise about code smell, and the three together, we start working like that. It came out very good. We have so much good feedback. So I think it's time to do one for Connascence as well.
And right now, thinking about distributed system and these kind of things, in like there are even
yes,
more
yes.
difficult ones.
Perhaps the list of Connascence that we can do will be bigger in the next year. We need definitely to expand the list. Actually, if you have any idea about some different kind of Connascence, let us know. Yeah. Unfortunately, without having a vocabulary to talk about that, it's really hard to solve it. Because if you say, oh, there is connascence of algorithm in these two components, it's a quick way to deliver the fact there is a big problem in there. But if you, no, in this component we do the same thing here, and then in the other one I see the same. You know, the listener is already tired to listen to it. It's like, yes, the developers has fear of everything, right? So you say, oh no, here there is connascence of algorithm. And then, oh wow, it has a name, this stuff. It must be really bad, right? So I think that's the use of connascence.
Thank you, Marco.